Okay, we're with Jeff Macare of Reef Dynamics today, and we're here discussing protein skimmers. What we'd like to discuss in this particular part is the design and the materials used in a protein skimmer and what really makes them beneficial one over the other. So Jeff, can you tell us a little bit about the design and the materials used in the Reef Dynamics skimmers?
Well, in any protein skimmer there are some very essential core design elements. Bubble size, volume of air intake, contact time, and then the way that the foamate is produced, which is essentially from kind of here up.
Okay.
So you've got here down and here up.
Okay.
So we'll start with the here down. We talked about last episode about the different types of induction and ways to make the bubbles. Once you have the bubbles created and injected into the chamber, this is one of the most critical components, because if the chamber is too small, you won't get proper contact time. If you read one of the more well-known traditional marine aquarium handbooks by Stephen Spotty, he talks a lot about skimmer design in one of the sections. And there's a very interesting point in there where he talks about that past 4 feet or 5 feet, there's not much reaction that happens as the bubbles rise. And that was originally referring to the straight, what they call co-current protein skimming, where the bubbles from the air stone are rising to the top, injected in the bottom, rising to the top. And then it goes the same for countercurrent protein skimming, where the water in that water is flowing against the flow of the bubbles.
Okay, so co-current means together the water and the air bubbles are rising in the same direction?
Right, yeah, they're coming from the bottom of the skimmer and rising up to the top and exiting.
And then countercurrent means?
That the water's coming into the top of the skimmer and exiting out the bottom, flowing against the rising bubbles.
Which are coming in at the bottom of the skimmer and working their way to the top. So they kind of have to fight each other as they go down there.
Exactly, yeah.
Okay.
So since the contact time is important, and you have limitations in saturation at heights, say 4 feet, for example, which is it's commonly known, then you really want a skimmer that's fatter and shorter.
Okay.
And there's a lot of reasons for that, especially in the more modern skimmers like the Reef Dynamics skimmers, because when you're using a pump to induct air and water and fill the chamber, the efficiency of that motor is affected by a number of different things. The water level in the sump, for example, in a flow-through system where the skimmer is using a pump to pull water and air in to fill the skimmer. And so, for example, on here you can see where this inlet is set on the body relative to the top and bottom of it is crucial to the efficiency of the motor.
Okay.
Because if I raise this pump up 1 inch, it would change the amount of air coming in.
Okay.
Which would affect the amount of air going into the body, bubbles, the volume of bubbles produced, surface area, all those things get dramatically affected.
And why are those things affected?
Because the atmosphere, basically.
Okay, pressure.
Right. The more pressure there is on this discharge right here, then the more back pressure on the motor.
Okay.
Which means it's harder for the motor to push the water through.
Okay.
So if I put this pump, for example, on its side, right, and put it all the way in the bottom, a lot of people think, well, that's better because now we're filling the chamber with more bubbles, right?
Right.
But the problem is that you're actually filling the chamber with less bubbles, because the pump in that configuration is pumping against almost all the cylinders' head pressure.
Okay.
So it's pulling in less air and pulling less water.
Right? Okay.
And that's kind of like a lead into one of the things that I wanted to talk to that might be a little controversial, and that is the advent of bubble plates. And it's kind of the rage now. All the skimmers, quote unquote, have them, except for ours. Obviously, they're missing. And there's a reason for that.
And a bubble plate is what?
Oh, a bubble plate is a chamber within the main reaction chamber where water is injected into, and there's a diffusion plate that allows turbulence to be minimized. And the idea behind it is to make sure that there's minimal turbulence inside the reaction chamber, so you can get good contact time, but also get a stable foam head.
Okay.
And the original reason that the bubble plates were designed is there were some very large skimmers being made, very large diameter skimmers, I think 20 inches or plus in diameter, but they were only 3 feet tall. And they were trying to get as much air into that small reaction chamber as possible, optimizing the contact time of the large round chamber. And so they were using multiple pumps. One of the problems they ran into is with all those pumps, They were filling the chamber with all kinds of air, but there was too much turbulence to create a stable foam head. So they created a bubble plate inside the skimmer, and all the pumps injected the water and air into the bubble plate, which diffused that turbulence and allowed the water and the bubble in the chamber to react in a calmer way.
Okay, so kind of a little bit of a baffle.
Yeah, it's
okay.
diffusion.
Okay, diffusion, okay.
And it was critical for that type of a skimmer.
Okay.
The problem is someone saw that and thought, oh, I should put that in my skimmer.
Oh.
It'll probably work, probably help. Well, the problem is it doesn't provide any function. It actually is a drawback to skimmer function and design in smaller protein skimmers because you have to put that pump lower in the body, so you've got more back pressure on the motor, less air is being taken in, more water being taken in, the ratio changes. And on top of that, you're forced to have a section of the reaction chamber that it has to be devoid of bubbles, because the bubbles are now leaving the top of the diffusion plate, the bubble plate, which is going to be at least 2 or 3 inches up inside the reaction chamber. And from there down, if you have a lot of bubbles, they're going to get sucked out the outlet assembly and go into the tank. So typically speaking, when you see a protein skimmer using a bubble plate, depending on how tall the reaction chamber is, and again, good design is going to have a shorter reaction chamber and a larger diameter, you'll end up seeing that half the chamber is full of bubbles instead of 3/4 of the chamber being full of bubbles or 2/3 of the chamber being full of bubbles.
Okay.
And that's out of necessity.
Okay.
And a product of design. And to be honest with you, when these things were first coming out, of course, we experimented with it. We built skimmers like that. And what we found was putting this model with the bubble plate and another model without a bubble plate right next to it, this skimmer outperformed it like 5-to-1.
Okay.
And you could see, looking at the chamber, that this chamber was like 3/4 full, and the other chamber had to be halfway full, maybe a little bit more than halfway.
Okay.
And right away, I saw that and I thought, wow, we're losing huge amounts of contact time.
Oh.
So, again, there is a time and a place for it, especially with large industrial skimmers. If you're going to use like big jacuzzi pumps, for example, and you want to keep the pressure on the pump down, so you're using a big diameter chamber. Like I've seen skimmers that are like 4 feet in diameter, but 6 feet tall. Right? Instead of being 20 feet tall, a la some other well-known industrial brands that are in many public aquariums right now. And it's a very inefficient design, inefficient from many, many ways. Not only power consumption, but just air creation. None of those are using induction. Unfortunately, I don't know why that technology is not getting out there. It's something I have to do. But again, for large aquariums with big, huge pumps, with large volumes of water and high velocity, diffusion makes sense. And a small skimmer, as you can see here, when we originally designed these products, we realized that the best place for diffusion, and in most early skimmers, the place for diffusion was at the neck. Like in the early Sanders skimmers, if you remember them, they all have that little cross grid.
Yes,
right
yes,
at the neck.
yes, I do.
That's for diffusion.
Okay.
And so this would be a great place for diffusion, but the problem with the crosshatch is that it ends up interrupting the flow of bubbles and foamate.
Right.
So what we did is we created this transition, and this is a very unique product. Ours is the only product that has it in the United States, and we brought it here, this design to the United States. So what happens here is that as the water rises slowly up the chamber, it gently is pushed by this little arc towards the reduction size. So you're going from 8 inches here to 4.5 inches here.
Okay.
So it slowly reduces with an arc and gently pushes that bubble into this neck. So you can see as this water is moving through, it's a very nice flow.
Okay, yes.
It's not a lot of whipping turbulence and stuff like that. And this is where we get our diffusion, which allows us to have the pump in a better position, more air, better contact time, all the way around.
Okay, okay.
So
what we've been discussing here is the benefits of what's called a bubble plate, and it seems to be more of a design issue that benefits large protein skimmers as opposed to the smaller ones, which typically a hobbyist would use. And in this particular case, we've got a design feature here that allows a smooth transition of air bubbles from the main body as it reduces down into the neck of the protein skimmer. So tell us a little bit about once the air bubbles get moved into the neck here and what happens from there.
Well, the neck is a very critical part of the design as well, because if the neck is too small, it's going to force the foam into a place where it's not going to have enough time to stabilize and create that foam head, that foamate, that thick foamy, kind of like when the beach gets all washed up after a storm, that really dense foam. So if the neck is too wide, you won't get a stable foam head either. So this diameter here is critical to its relationship to the diameter of the body, the size of the motor, the amount of air and water being ejected into the reactor. So those things are all critical. Physics type design. sort of parameters. And another thing that I think is also important, not so much in terms of efficiency, but in terms of serviceability, is making sure it's easy to get the cup off.
Yes.
And one of the things, early protein skimmers that I worked on, we used large Schedule 80 unions, which you turn and turn and turn and turn and
And turn
beer,
and turn and turn
come
and
back
turn and
keep
turn.
turning, and then they eventually come off. And
I still work on a few of those.
and that design it was. After that came people who were making, the thumb screws, 500 thumb screws. Again, take a vacation, come back, finish the thumb screws. And then from there, we went to a bayonet, which was kind of like a puzzle lock fitting, where there were tabs that set into a female section, and you twist it, and it would seal with the O-ring. And I looked at all that, and I thought, there's a better way to do all that. And so I designed what I call the jam lock, which is basically a quick release. Looks like a union, but instead of all the turns, it's bink. That's
Quarter
loose.
turn.
The collar comes up, and then you just slide the cup right off.
Oh, that's real slick, and that's easy.
So there's no lifting required.
Right.
And that's one of the selling points, is that there's no vertical clearance.
Right,
so if you've got a 24.5-inch cabinet,
Yes.
the skimmer will work.
Right.
Whereas any other skimmer, bank, you can't get the lid off.
Yeah, a lot of applications I've had to take in consideration. How tall a skimmer can I get?
Yep.
But if I have to lift the cup up even further, then I have to take that into consideration for the inside height of my cabinet.
Yeah. And it's just fast. I mean, if you're going to clean this thing, boom, you're off. So, but anyhow, that's pretty much it. Oh, and it's really important that there's holes in the lid, because if you don't put holes in the lid, it'll percolate like a coffee pot.
Now,
the air's going to go someplace.
Right, those holes, they allow the air. I mean, those are air bubbles that are basically popping or exploding inside there. That air has to get out somewhere.
Yep.
Okay, hence the reason for those holes up in the top.
Yep.
Okay, so there's a little information about design of protein skimmers, a comment about the bubble plate. Make sure to come on back for part 3 as we discuss a little bit more about the protein skimmer and some of the benefits of one versus another. Oh, yes. Okay, go ahead.